Hello, everyone. Welcome to the first part of our webinar regarding point-on-wave switching. My name is Rosemary Sun. I have been working in the field of substation automation and protection for more than 30 years, with different roles and have lots of experience both in technical and market side. Now, I'm working in the marketing department, help to promote our products and the solutions. Today, together with our expert, Yeshon Soleminov, we will present you the overview of point-on-wave switching based on CPROTEC 5. Yeshon is our promoter and a technical expert for high-voltage protection. Please note that you will not be able to pose your questions directly during the presentation. Nevertheless, you are already invited to insert your questions in the Q&A box, located in the top right corner of the window once you exit the full screen mode. Simply switch from the chat tab to the questions tab and insert your questions there. Directly after the session, our expert will address your questions live during the Q&A. If we should run out of time during the Q&A, questions which have not yet been answered will be answered separately by email. Furthermore, you will have access to the on-demand recording of this webinar right after the session. Yeshon, now the stage is yours.
Thank you, Rosemary, for this introduction, and good morning everyone out there. It's a pleasure for me to conduct the first part of our webinar series about point-on-wave switching based on CPROTEC 5. Our first part is the introduction. Point-on-wave switching is basically a controlled switching, which allows to eliminate switching transients. So the first question you might probably have is, why do we need point-on-wave switching? Point-on-wave switching minimizes electrodynamic and dielectric stresses of switching devices as a result of controlled switching operation. Thus, aging of equipment can be reduced and lifetime can be extended. Furthermore, the maintenance intervals of circuit breaker can be increased, which lead to less downtime and high availability of the system. Also, the power quality in the system can be improved. As shown here, a capacitive load called cap bank was energized. On the left-hand side, the instant of closing was at the voltage peak, and severe voltage transients are thin. These transients have the potential to severely damage plant and equipment, including the energized capacitor itself. On the right-hand side, the same capacitor was energized correctly with point-on-wave switching, close to the zero crossing of the voltage. So there are almost no induced transients due to the closure. The advantage of the point-on-wave switching is very clearly demonstrated in these diagrams. So another application for point-on-wave switching is switching an inductive load. Inductive loads, such as transformers and reactors, typically have iron cores. When these iron cores saturate during closing, as shown on the left-hand side, there will be a severe inrush current during switching. On the right-hand side, you can see an inductive load controlled by point-on-wave at peak voltage. The flux dashed lines will have no offset and will therefore have no inrush current. So, to summarize on previous two slides, we can say point-on-wave switching is useful for the following switching application: shunt reactors, transformers, capacitor banks, filters, lines, and cables, no compensated lines. So let's move now to the advantages of point-on-wave switching. Here you can see the table with advantages of point-on-wave switching. For inductive loads like transformer and reactor, reignition and overvoltage can be reduced during switching off, and inrush current during switching on. For capacitive load like cap bank and transmission lines, restrikes and overvoltage can be reduced during switching off, and overvoltage during switching on. Let me explain shortly what are restrikes and reignitions. Reignition is for inductive load. It's happening directly after zero crossing of inductive current. Restrikes is for capacitive load. It's a voltage appearing half cycle after the zero crossing of capacitive current. This voltage can be very big and can damage the capacitor. Both restrikes and reignition can lead to high transient and even damage circuit breaker and other equipment. As you can see on the slide, reducing inrush current will help increase lifetime of the circuit breaker because mechanical and electromagnetic stresses can be decreased. Minimizing overvoltage will help to lower aging of switching equipment and increase reliability of the system. So the optimal switching time for point-on-wave switching depends on the load type. As reactance represent high resistance to the grid, the best switching time will be at near current zero crossing, which means at maximum voltage. These are the orange points on the diagram. Capacitive load, on the other side, represents low resistance to the grid and should be switched on near voltage zero crossing. These are the blue points on the diagram. This is the basic strategy for point-on-wave function. So let's move now to the hardware part. Point-on-wave switching in CPROTEC 5 can be ordered in 3 different combinations. As a standalone device, switching device 6MD86. For that, you should select variant K10 in CPROTEC 5 configurator. Also, as a bay control and point-on-wave switching device in one single device 6MD86. For this option, please choose all other variants besides K10. And, of course, as a protection, bay control and point-on-wave switching in one physical device. Here you have a variety of choices to select from. Probably here the choice will depend on the protection device types you need. So, in this slide, we will discuss circuit breaker requirements to realize point-on-wave function. The first important condition is that circuit breaker must be phase segregated. In other words, you must be able to switch each phase independently. This you can see on the diagram on the right-hand side. Please note that IO209 module with high-speed output contact are necessary. One IO209 module has 4 high-speed output contact. That means if you need to do point-on-wave for closing and opening, you need to the IO209 module. CT and VT inputs will be connected to IO202 module, which is part of the basic module. The position of the circuit breaker can be received with standard auxiliary contact, which are connected to IO202 module. If you have Siemens circuit breaker, then reference contact with more accurate switching position can be connected to IO218 transducer input. If you need to include ambient temperature, control voltage, or hydraulic pressure for more accurate response time, then IO218 module can be used as well. So let's summarize all hardware components together. You need basic module with IO202 for reference voltage and switching monitoring or recording. Then 2 IO209 module for CB opening and CB closing. IO218 module optional for CB monitoring like DC voltage, pressure, temperature, and reference contact like Siemens circuit breaker. Alternatively, you can use one plug-in module with 4 normal speed transducer input. Here you can see that point-on-wave function is applied to the function group circuit breaker 1 3-pole. Measuring points on the left-hand side, like voltages and currents, are connected to the function group circuit breaker. On the right-hand side, you can see binary input and binary output are connected to the function group circuit breaker. The close and/or open command issued via the control function of this circuit breaker will be the point-on-wave switching operation. In this manner, the point-on-wave function is fully integrated into the standard control logic of CPROTEC 5, for example, close command via IEC61A50. So let's summarize point-on-wave function. So point-on-wave function with CPROTEC 5 brings all the platform features to the point-on-wave device, like modern Ethernet communication like IEC61A50, Goose, redundancy, etc. Cybersecurity like role-based access, RBRC, security event logging, syslog, secure communication. Strong engineering tool DXi5 with its all function. Device access with Ethernet browser. Point-on-wave function can be combined with other functions as well, like bay controller, transformer protection, etc. All standard point-on-wave functions are available for closing and opening. Also, detailed process data for analysis and adaptation during commissioning can be done with SIGRA. So thank you for your time. Hope you have enjoyed my presentation.
Thank you, Yeshun, for a wonderful presentation here. So we have already several questions from the channel, so let's answer them. Yeah.
Sure.
Here's the first question. how point and wave functions if you have a fault and need to trip the circuit breaker?
Well, if you have a fault and you need to trip a breaker, then there is no point-on-wave function inside because you are tripping the breaker directly. Remember, point-on-wave function is necessary if you are doing control switching, naming, closing, or opening the breaker.
Okay, good. Then we have another interesting question. What is the advantage of having point-on-wave in Cyprotec 5 in comparison with point-on-wave standalone device from another manufacturer?
Well, this is a good question. With point-on-wave function in Cyprotec 5, we bring all the platform features of Cyprotec 5 together. That means that you can have like cyber security features, communication protocols, and engineering tool DXi5. And of course, you can do evaluation with our tool SIGRA.
Yeah, that's a good answer for that. So here comes another interesting question. Is it necessary to have IO209 module for point-on-wave function?
Yes, it is very important to have IO209 module for point-on-wave function because the IO209 module has high speed the output contact, and these contacts are obligatory for point-on-wave function.
Yeah, good answer. So then we have another also very interesting question need to be answered. Can point-on-wave be realized with sample measurement values from merging unit 6MU85?
Yeah, this is a good question too. Currently, it's not possible to realize point-on-wave function with sample measured values 6MU devices because they are not fast enough to operate for point-on-wave function. Remember, with point-on-wave function, we're working within the millisecond range. However, if you have 6MU85 and 6MU85 has a hardwired connection to the current and/or voltage, and also like a binary input signal from a circuit breaker zero contact, then you can of course realize point-on-wave function in such a device itself.
Okay, so we have all the questions answered so far. So thank you very much, Yezhen, for this kind of wonderful presentation and also the Q&A part. So thank you also again for the auditorians. So we have to close the session and wish you a good time and stay safe.
Thank you.
Bye-bye.
Bye-bye.